Imagine standing on a dry plain that stretches endlessly toward the horizon. The ground is covered in reddish dust. The sky above is tinted in orange. There is no sound of wind, no rivers running, no birds flying, just silence. Now imagine this is not Earth, but Mars. For billions of years, this lonely planet has guarded a question beneath its rocks. Was it ever alive? And today, with the help of robots like Perseverance, we may finally be closer than ever to finding an answer. Let's turn back the cosmic clock 3.5 billion years ago. Mars was not the cold, dry desert we see today. Instead, water flowed across its surface. Valleys were carved, rivers joined together. Some led into a giant crater we now call Jezero. Scientists believe this crater once held a massive lake, a body of water that may have lasted for millions of years. A place where sediments settled, chemistry unfolded, and maybe, just maybe, life could have taken its first steps. That's why, in 2021, NASA chose Jezero as the landing site for its Perseverance rover. It wasn't a random choice. It was like searching for life's diary in the most likely hiding spot. And Perseverance has been busy, rolling across the crater floor, collecting samples, scanning rocks, flying a tiny helicopter, the first aircraft ever flown on another planet. Every move designed to answer one question. Did life once exist here? In 2024, Perseverance made one of its most intriguing discoveries yet. At a site named Cheyava Falls, within the old river channel of Neretva Valleys, it encountered a rock unlike the others. At first glance, it looked ordinary, but up close, its surface told another story. Strange spots covered it, white patches surrounded by black halos, forming patterns like leopard skin trapped in stone. Curious, the rover pointed its instruments. Sherlock, a device built to hunt for organic molecules, scanned the rock. It detected carbon-based compounds, the very building blocks of life. PIXL, a powerful X-ray spectrometer, studied its chemistry. It found minerals like vivianite and greigite. On Earth, these minerals often appear in watery environments, alongside microbial activity. The discovery made scientists pause. What were these patterns? Could they be the fossilized whispers of ancient Martian microbes? Or could they simply be chemistry playing tricks again? The findings were published in Nature in 2025. The research team explained the chemical combination in this formation could provide energy sources for microbial metabolism.
Listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting.
That's a bold claim. Not proof, but a clue. And in science, clues matter, especially when they connect with the bigger story. Think about Earth. In ancient lakes and the swamps, microbes often leave behind minerals just like this. Vivianite, an iron phosphate, forms in sediments rich in decaying organic matter. Greigite, an iron sulfide, sometimes emerges through microbial processes. Both, when found together with organic carbon, tell a very specific tale: water, chemistry, and energy. All ingredients for life. But here's the problem. Nature is clever. Similar minerals can also form without life, through heat, through acid, through purely geological pathways. And Mars has tricked us before. In 1984, a meteorite found in Antarctica appeared to show fossilized Martian microbes. Headlines shouted, "Life on Mars." Years later, careful analysis revealed a more mundane explanation: geology, not biology. That's why today's scientists are careful. They don't declare victory. They say, this is a potential biosignature. Not life itself, but perhaps the strongest sign we've ever seen. But how do we know for sure? We need those rocks here, on Earth. Only with advanced laboratories can we study their chemistry down to the atomic level. That's the purpose of the Mars Sample Return mission. Perseverance has already sealed more than 30 samples in titanium tubes. They're waiting. But bringing them home is no simple task. We'd need a lander big enough to carry a rocket small enough to launch from Mars, an orbiter strong enough to catch it in space and bring it back, a cosmic relay race 200 million kilometers away, But here's the challenge: cost. Originally, NASA thought it would cost about $6 to $7 billion. Now the estimate has ballooned to $11 billion. And even if everything goes well, the earliest those samples might reach Earth is sometime between 2035 and 2039. Meanwhile, China is preparing its Tianwen-3 mission, aiming to return Mars samples too. Some say they might even get here first. It's a strange irony, isn't it? We may send astronauts to Mars before we manage to bring back a single rock. Let's step back for a moment. Jezero Crater. Why that name? It comes from a small village in Bosnia and Herzegovina. Jezero simply means lake, a fitting name for a place on Mars, believed to have once been full of water, and the rover's current path takes it through Neretva valleys, named after the Neretva River, the same river that flows under the iconic Mostar Bridge in Bosnia. Think about that. A bridge on Earth, a valley on Mars, both connected not by geography, but by names chosen by scientists. A symbolic bridge between worlds. It reminds us that space exploration is not just about machines and rocks. It's about culture, history, and human curiosity. We bring Earth with us, even to Mars. Let's imagine for a moment. What if the patterns Perseverance found are truly biological? What if those little minerals are the remnants of microbes that lived billions of years ago, when Mars was warmer, wetter, and alive? That would mean life is not unique to Earth. It happened twice, in two neighboring worlds of the same solar system. And if life happened twice here, what about elsewhere? The Milky Way holds more than 100 billion planets. If just one more hosted life, then life is not a cosmic miracle. It's a cosmic rule that would change everything. Religion, philosophy, science, our sense of identity. We would no longer ask, are we alone? Instead, we would ask, where else are they? And maybe, just maybe, Mars could become the first step toward answering that. But what if the opposite is true? What if these clues turn out to be purely chemical? What if Mars is lifeless, and always has been? Even then, the discovery is valuable. It tells us how fragile life is, how rare it might be, and how much we must protect it on Earth. Sometimes answers shape us. Other times, the lack of answers shapes us even more. So let me ask you, if life once existed on Mars, tiny microbes thriving in ancient lakes, what does that mean for us? Carl Sagan once said, if life is only on Earth, it's a miracle. If it exists on 2 planets, it's everywhere. Think about that. A galaxy with 100 billion planets. If life emerged on just one more, the universe is not empty. It is alive. Maybe Perseverance didn't just find rocks. Maybe it found a mirror, a reminder that life is not a rare accident, but a natural outcome of the universe. And if that's true, then the real question becomes, where else is life waiting to be discovered?